Now, to solve some problems and equations to understand logarithm even better. Just remember, seeing is only 10%, doing is 80 and the remaining 10? We'll call it luck. We encounter basically three types of problems in log. The first ones are the simple ones, where we evaluate, or find the value of something stated, something like x. It's a clear case of mathematical simplification, that's it. The second types are the problems where we need to prove an equation. They usually state an equation and we prove whether if left-hand side equates to the right-hand side. We don't really reach an answer in this, but the process is the answer. And the third type is where an equation is stated, and using that relationship we need to prove another statement. These are a little tricky, but still easy when practiced a bunch of times. Let's look at type 1 basic problems here. We have to express the given exponential function in the form of log, that is log to base b, of y equals x. First, we have 2 to the power of 5, which is 32, and in log form, we get the log of 32, with 2 as its base, and 5, the answer. Another similar example we see is with 7's cube, which is 343, and in log form, we get log of 343 to base 7 and 3 as its answer. Easy, right? How about exponent, with negative powers like 3 to power minus 2, which is 1 upon 9, and in log form we get log of 1 upon 9 to base 3, which equates to minus 2. Another one we see here is 81 to the power of 1 upon 4, which equates to 1 upon 3. In log form we get this as log of 1 upon 3 to base 81, which equates to minus 1 upon 4. In the next set, we need to show the given log equation in exponential form. The first problem we have, log of 1 upon 36 to base 6 equals minus 2, which in exponential form becomes 6 to power minus 2 equals 1 upon 36. Another problem we see here is log to base 10 of 1000, which in exponential form becomes 10 to power 3 equals 1000. Remember, we never let negative numbers and fractions scare us, and solving these problems should be no problem at all. The next set of problems requires us to solve the log and find the answer. Let's take an example of log to base 8 of 64 is what? And to solve it, we will assume the answer is x. And reverting the equation back to the exponential form we see 8 to power x equals 64. We can simply get the answer by observing here that 8 squared is 64. So 8 to power x must be equal to 8 squared. And comparing the power we see that x equals 2, hence the answer of log to base 8 of 64 is also 2. Let's take another example pretty much similar to this one. Log to base 64 of 4, here also we assume the answer is x. And revert the equation back to the exponential form, we see 64 to power x equals 4. 4 cubed is 64, so we will substitute 64 as 4 cubed. And we now compare the powers. Since the argument is the same, we get 3x equals 1. Here we take the 3 to the right hand side, giving 1 upon 3, hence, the answer to log to base 64 of 4 is 1 upon 3. Moving on to next one, we have an interesting problem. We have a log to base 5, and this log is operating on another log, this one with base 3, of 3. If you're wondering, can we do this? Yes we can, it's completely legit, and we can apply as many logs to a variable or number, as much we can handle. This requires inside work. What I mean by that is, we need to solve inner logs first, and then come out gradually. So we solve log to base 3 of 3 first. And as we know, log of a number to the same base is always 1, so for log 3 to base 3, we get 1. Now we solve log base 5 to 1, and here we know, log to any base of 1, is always 0, so the log to base 5 of log to base 3 of 3 is 0. This question states, the log to base of 48, of 4 square root of 3, and we need to find the answer to this. The first thing we do notice here is that 4 square root of 3 when squared gives us 48. We keep a note of this. Now we use the base change rule, with new base as e, which is an exponential variable. We get log to base e, of 4 root 3, upon log to base e, of 48. And in next step, we substitute the noted value of 48 as 4 root 3 squared. We use the law of log of power here, and we take the power 2 out from the denominator. And naturally, the numerator and denominator both cancel out each other, giving us our final answer of log to base of 48 of 4 root 3 as 1 upon 2. Log to base 2 of root of 32 upon root of 8. Boy, that's a wordy problem. Here we will use log of power, since we can take root as power 1 upon 2. And we get half multiplied by log to base 2 of 32 upon root of 8. Further, we use log of quotient and get log of 32 minus log root of 8. Here we see that 32 is the result of 2 power 5, and 8 is a result of 2 power 3. So the root of 8 becomes 2 to the power 3 by 2. And then apply the log of power again. And we get 1 upon 2, multiplied to whole of 5 times log to base 2 of 2, minus 3 upon 2 times log to base 2 of 2. And since log of a number with the same base is 1, we are left with 1 upon 2 multiplied to whole of 5 minus 3 upon 2. Which finally gives us the answer to log to base 2 of root of 32 upon root of 8 as 7 upon 4. The next problem states log to base b of root b minus log to base a of 1 upon a. And we need to find the answer to this. One might wonder, how are we supposed to find a numerical answer to a question full of only variables? I'd say with patience. With patience and practice it is possible. Since we do know log of reciprocal of a number is log of same number times minus 1, we substitute this in the equation and get plus log to base a of a. Now we use the property of log of a number with same base, which is always 1, which makes log of a to base a as 1 and gives us log to base b of root b plus 1. Root of a number can be stated as power 1 upon 2, and after stating that, we use law of log of power again. Which leaves us with log to base b of b, which is obviously 1. Which gives us 1 upon 2 plus 1. So the answer to log to base b of root b minus log to base a of 1 upon a comes as 3 upon 2. The next problem needs us to evaluate 18 to power of log to base 3 times root 2 of 7. Look carefully, it's 3 times root 2 and not cube root of 2, don't make reading mistakes like these, ever. Here 3 times root 2 when squared will result in 18. And after observing that, we will use it in the problem to get 3 times root 2 to power 2 times log to base 3 of root 2 of 7. We'll go ahead and make the 7 squared because of law of log of power. Here we use a rare formula of a log. Any number b raised to log to base of same number b of x will lead to the number x itself, which when applied will lead to just the 7 squared, that is 49, which is our final result. Express in simpler form or in single logarithm form. These are easy to solve, only to those who know when to stop. We want to make the given equation to have fewer log variables as possible. To show you what I mean by that, I will demonstrate it to you in the next example. Log to base 2 of 6 plus log to base 2 of 8 minus log to base 2 of 3. We use both log of product and log of quotient and get log to base 2 of 6 times 8 upon 3. Here 3 and 6 cancels out to become 2, so our final answer is log to base 2 of 16. However, we can solve this even further. If we resubstitute 16 as 2 to power 4 and use log of power here, we get 4 times log to base 2 of 2, which obviously becomes 1, which results into answer being 4, which is not what we needed. We needed only log to base 2 of 16, which is the simpler log form, which was asked in the first place. On to the next one. We have 1 upon 2 multiplied 2 log of 9 plus 1 upon 3, multiplied 2, log of 27. Here we use log of power to get log of root 9, plus log of cube root of 27. Root 9 is 3, and cube root of 27 is 3. Further, we use log of product to get log of 3 times 3, which leads to the final answer as log of 9. Here we can see the base is missing, and we know if base is missing we always assume it to be e. However, we didn't need base here, because we need to find the simplest log, and that stops at log of 9. On to the next problem, we have log of 1 upon 2 minus log of 5 upon 6, plus log of 3 upon 4 minus log of 7 upon 8. Here we use log of quotient to get log of 1 upon 2 divided by 5 upon 6 plus log of 3 upon 4 divided by 7 upon 8, which later becomes 1 upon 2 multiplied by 6 upon 5 plus log of 3 upon 4 multiplied by 8 upon 7, which then further leads to log of 3 upon 5 plus log 6 upon 7, and after that, we use log of product on the next page. Log of product leads to log of 3 upon 5 multiplied by 6 upon 7, which gives us our final answer as log of 18 upon 35. In the next problems, we will be needing to find x or solve for x. For the first example, we'll see log to base 5 of x equals 2. We convert this equation into exponential form to get x equals 5 squared, which is 25, easy right? Let's take another interesting problem, log to base 5 of x squared minus 5 times x plus 11 equals 1. We convert this equation to exponential form to get x squared minus 5 times x plus 11 equals 5 to power 1. Taking 5 to the other side, which in next step gives 11 minus 5, which comes as 6. And we now need to solve this quadratic equation to find x. We take factors 2 and 3, and to find the answer of either 2 or 3, we substitute both these values in our question to see which value satisfies the equation. For x equals 2, we get 2 squared minus 5 times 2 plus 11, which leads to log to base 5 of 5, which is 1, which totally satisfies the equation. And for x equals 3, we get 3 squared minus 5 times 3 plus 11, which also leads to log to base 5 of 5, and that also satisfies the equation. Hence both x equals 2 and x equals 3 are the solution for the given question. For the next problem we have log to base 3 of x plus log to base 3 of 4 equals 2. Here we need to find value of x in the mentioned equation. We first use the base change rule with a new base as e. We get log of x upon log of 3 plus log of 4 upon log of 3. Now since the denominator is same, we add them up to get a common denominator of log of 3. Which further we will transfer to the right-hand side of the equation, where it will be multiplied with 2. Here we use log of power to get log of 3 squared. And in next step, we transfer log of 4 to the right-hand side to get log of 9 minus log of 4. And now we use the log of quotient here to get log of 9 upon 4. Finally we cancel out log on both right and left side, or we can say we took anti-log, which will lead to our final answer, that is value of x, which is 9 upon 4. The next problem might look a bit difficult, or tough to solve, but remember, looks are not everything. E to power, sine of x, equals 1. Here we need to find the value of x. At first glance we don't get that. This problem will require log, but we do indeed. We use log by inverting this exponential function. We get sine of x equals log to base e of 1. And we know very well that log of 1 with any base is always 0. This leads us to sine of x equals 0. And sine function yields 0 only if its angle is 0 or multiples of 360 degrees, so the value of x is 0. This really was an easy one. For the next problem we have log to base 2 of log to base 3 of log to base 2 of x equals 1. Here we need to find the value of x. We will convert this log into exponential form, and we convert it into exponential form by picking the innermost log first, and we work our way to the outer log, step by step. First, we have 2 to power 1, which is 2 itself. And further converting to exponential form, we get 3 squared, which is 9. And after applying final conversion, we get 2 to power 9, which is 512, which is our value to x, or our final answer.